Hello everyone, this is Priya Nandwani from ITM University Gwalior, and this is my presentation on IoT-based home automation system. Before moving forward, I would like to thank Emertxe Information Technologies for providing me this opportunity and also our project guide Jayalaxmi Ma'am who have supported us throughout this journey and also made difficult concepts very simplified and very easy to understand. So, moving forward, these are the contents that I have covered in the presentation, and this includes introduction, C programming, and C++ programming, embedded systems, IoT, Blink app, about project, and also about the project requirements. And at the end, I have included the simulation of the project. So, moving on to the introduction part. So, basically, in this internship, we have implemented an IoT-based home automation project, and we have actually integrated Blink app with it that makes it uh, IoT based because it can be accessed from anywhere in the world through the internet in which we are basically controlling a cereal tank, garden lights, and a heating and a cooling system. And we are also displaying it on the Blink app, and also we are displaying it on the CLCD screen. Through the Blink app, we are also monitoring and controlling different widgets. So, moving forward, let's understand about all the concepts that we learned in C programming throughout this internship. So first of all, introduction to C programming. So we know that C programming was developed by Dennis Ritchie in the early 1970s, and it is a general purpose language. It is a procedural programming language, and it is very close to the hardware, hence it is generally used in game development and also in embedded systems because we generally want less delay in these systems. And C programming is known for its efficiency and control over hardware. We learned about different data types, which include primary data types, which include int, char, float, double. Signed data types, which include positive as well as negative values like signed int, signed char. Unsigned data types like unsigned int, unsigned char, which include only positive values, unlike signed data types. We also learned about derived data types like arrays, pointers, structures, unions, and also we learned about the void, which is basically used for functions returning no value. So moving on further concepts, we learned about variables and constants. So variables are basically containers which can contain some different types of values like integer, float, double, and we can give it particular names as we like. But there are also certain conditions associated with variables because we cannot name variables with special characters, and we also cannot name a variable starting with a number. So there are some specific rules that we learned in this internship, uh, how to basically name a variable, and constants which basically do not change throughout the program execution. For example, if I write at the starting of the code hash define pi equals to 3, hash define pi 3.14, so wherever in the code I will use pi, so it will be automatically replaced by 3.14. Moving on to the operators, we learned about different operators like arithmetic operator, which includes plus, minus, multiplication, division, modulo. Then relational operators, which includes double equal to, not equal to, greater than, less than, greater than equal to, less than equal to. Logical operator, which include logical and, logical or, logical not, and bitwise operators. which include bitwise and, bitwise or, bitwise XOR, bitwise not, left shift, right shift, assignment operators like assignment operator, which is basically an equal to, then uh, this is an operator which is basically if we write b plus equals to 2, so it basically means that b equals to b plus 2, minus equals to, multiplication equals to, and divide equals to. These all work on the same way. Increment and decrement operators like uh, plus plus, which is an increment operator, and minus minus, which is a decrement operator, which increase the value by 1 and decrease the value by 1. And also there is one more concept associated with it, is post increment and uh, post increment, post decrement, and pre increment, pre decrement. Uh, these are also the concepts that we learned throughout this internship. Now, moving on to the conditional operator. So, conditional operator is basically a small way, or basically a concise way to write an if-else statement. So, first of all, we give a condition, and if that particular condition is true, so we execute the part which is written between the question mark and the semicolon. And if it is not true, then we execute the part which is written after the semicolon. So this is all about the ternary operator. Now, moving on. Moving on to the control statements. So in control statements, we learn basic if-else statement. For example, if age is greater than equal to 18, so we can say that the person is an adult, and if it is not, then we can say that that person is basically underage. So those kind of statements we learned in this internship how to implement, and we also learned about nested if else. We also learned about if else statement. We learned about switch statements, and where we can use the switch statements. Uh, Also, we learned about different kind of loops. For example, for loop, while loop, do while loop. In for loop, basically, we know that number of times a particular loop is going to iterate. In while loop, we don't know how many times the loop is going to iterate. In do while loop, we want the loop to at least work one time. And we also learned about the pointers. Pointer is a very important concept in embedded system. And throughout this internship, we learned about the basics of pointer. And yes, basically int star PTR refers to where PTR is basically a pointer, which means that it is actually pointing to a memory address. A pointer is a variable that stores the memory address of another variable, and it is used for dynamic memory allocation, arrays, and functions. So one of the applications of pointer is that while passing an array to a function, we actually don't pass a complete array to a function because it is very uh, large in size. So we pass the address of the first uh, element of the array, because through the first element we can access the rest of the elements, because array is a contiguous memory. Basically, array is stored in a contiguous memory location, where the elements are stored uh, one after the another. They are not disintegrated in different parts of the memory. So moving on to further concepts of C, which include arrays. So, a collection of variables of the same type stored in contiguous memory location is an array. So, here we can see that here we have initialized an array of size 5, and each of the elements of the array all the five elements can be accessed using an index which starts from 0 and goes up to n minus 1, which is basically n here is the size of the array, which in this case is 5. So basically the indexing goes from 0, 1, 2, 3, and 4. Strings is a sequence of characters terminated by a null character slash 0, which is also a null character. And we can initialize a string by char str 10. 10 refers to the size of the string, and basically string is made of characters, but it is uh, basically it is made of characters, and here we can see that the size of the string is 10, and there are various functions we learned in this internship related to strings like strlen, which basically gives the length of the string, strcpy, which basically copies one string to the other string, strcat, which basically concatenates two string, strcmp, which basically compares the two string. str is also one of the function associated with string, which maybe it checks for a substring in a particular string. So moving on to the number system, we learned basically four number systems in this internship, which include binary number system, which include 0 and 1, octal, which is base 8, which includes digits from 0 to 7, decimal, which includes digits from 0 to 9, and hexadecimal, which is base 16, and it consists 0 to 9 digits as well as A to F digits. So moving on, we also learned about how we can convert binary to octal, octal to decimal, decimal to hexadecimal. Basically, how we can convert within these number systems is also one of the things we learned in this internship, especially hexadecimal, which is highly used in embedded systems. Now, moving to the input and output operations of the files, we learned about scanf and printf, which are basically normal functions, uh, which are basically functions provided by the C to print something on the output screen or to basically take an input from the user. There are also some functions related to the file input output, like fopen, which is basically to open a file, fclose, which is basically to close a file, fprintf is which is basically used to print a particular file, and also scanf, which is basically to take an input from the user. Now, functions. Functions are very necessary for our program, and functions are highly used because if we want to perform a set particular task, so we cannot write that the code for a particular task if it is a similar task over and over again. So we basically make a piece of code which can be used as many times as we want. We just need to call that function and it will perform that particular operation. So basically, there are three things associated with a function, which is function definition, which is generally performs a specific task. For example, if I declare a function of addition and I take two input variables, int a and int b, and I perform addition in a variable c, and I return that particular variable. So that definition is function definition. Function declaration is generally when we declare that function at the initial part of the code so that we can implement that function anywhere in that particular code, and we need not to initialize that function on the top of the code. We can also implement that function at the end of the main function then. So function declaration is generally considered a good practice, and function call is basically calling a function. For example, if I call a function add and I just give my number a and b, for example 5 and 6, so it will return me the answer, which is basically 11. So moving on to the shortcomings of C. So why we need to upgrade to other languages and not just stick with C, because C has some shortcomings. Like, the shortcomings of C include lack of object-oriented features, which is basically that C is a procedural programming language and does not support OOPS, which makes managing large code bases and modeling real-world problems more challenging. No direct support for exception handling. C lacks in built-in support for error handling mechanism like exceptions. Limited data encapsulation. In C, there is no way to define access controls like private or protected to prevent direct access to data. No direct support for overloading. C does not support function and operator overloading, limiting flexibility in function behavior. So these are some of the shortcomings of C. Like oops, we cannot relate real world entities in C, and there is no way we can use exceptional handling in C. There is no way we can hide some data or encapsulate some data in C, because everything can be accessed to everyone. And there is no support for overloading, which basically means that if there are two functions with the same name, so it will not be compiled properly. It will throw an error, which is not in the case of C++ because it supports operator overloading and also function overloading. Now moving on to the C++ programming. During this internship, our major focus was to learn C programming, but also we learned about some of the important concepts of C++ programming, though not going in so much depth into it. So basically, C++ is an extension of the C language, and it also comprises of object-oriented features, and it was developed by Jarne Strautstrup in the early 1980s, and it supports both procedural and object-oriented programming language. Now, using in C++, basically we can display something on the output screen using the cout, and we can take some input from the user using cin. As we can see in the example, that here we have written cout hello world and then endl. So basically we are displaying this on the output screen. Now, one of the important concepts of C++ programming is function overloading, which basically means that C++ allows multiple functions with the same name but different parameters in the same scope. And also operator overloading, which is allows custom definition for a standard operator, example plus minus, to work with user defined types. So basically function overloading, as I told before, that there are functions with the same name but different parameters, and they can be used in the same scope and it will not throw an error. And also operator overloading, which basically means that the standard operators can also be used with the user defined types. And basically an operator is used in a different way, not just in the standard way, but also it can be used by the user as per his or her convenience. So constructor and destructor. Constructor is a special member function that initializes objects of a class when they are created. A special member function that cleans up resources when an object is destroyed. So basically constructor and destructors are opposite of each other, because constructor is generally called when when an object is initialized, in order to create an object, a constructor is called when an object is initialized. So, that time constructor is called when we make an object. To initialize that object, to give it the properties, we use constructor, or basically a built-in constructor is automatically called. Whereas uh, destructor is also a special member function which is called automatically after the program stops executing and we need to clean up the resources when an object is destroyed. So while the when the object is made, that the constructor is called. When the object is destroyed, destructor is called. And STL is a sender template library, which is also one of the key features of C++ because it is very rich library which provides us with different features like collection of classes, functions, algorithms, iterators, data structures, vector, list, and also exception handling. As I also focused on the shortcomings of C, that C does not support exceptional handling, but C++ supports exceptional handling using the try and catch keywords. So here we can see try, and here this is a comment code that may throw an exception, catch exception type code to handle that exception. So moving forward. So, in order to understand all the concepts we learned just now in the C++, I have also included an example code. So, these are the header files, and this is a class definition, which is a class box. So basically, class is a blueprint of an object. So here we are initializing a box and we are making some private members like double length, double width, double height. Double here is a data type. And then we are also writing some part on the public, which is basically a constructor. And constructor, as I told before, initializes the dimensions of the object. So box which takes L, W, H, length, width, height. So this will print constructor called. So destructor is basically called when the object is destroyed, and this is representing function overloading because we can see that double volume, both the functions are same. The only difference we can see here is that it is not taking any parameter, but it is taking a parameter. So this is function overloading, and if we write these two functions within the same scope, it will not throw an error because C++ supports function overloading. And this is operator overloading, in which basically we are using the plus operator to add dimensions of the two boxes. Whereas generally plus sign we use to add two numbers, two float values, two double values, two integer values, but here we are adding the dimensions of the two boxes, which are basically two objects, and we are adding their dimensions. And here we are basically implementing that operator overloading. So here the operator which is being overloaded is plus operator, which is basically adding the properties of the box first and the box set second. Like we can see that it is returning a box which contains the length of the first box plus the length of the second box, width of the first box and the width of the second box, and the height of the first box and the height of the second box. And this is normal function in which we are basically calling which in which we are basically displaying the length, width, height, and this is the main function where basically we are making two objects of the class box one is the name of the object first, in which the length, width, and height are 3, 4, and 5. And basically, it is calling a constructor because we use constructor to initialize an object. And here is the box second. Box 2 is the name of the object, and we are initializing length, width, and height of the box second. And then we are displaying box 1 display, box 2 display, and this will be displayed. This information will be displayed of these respective boxes or objects. Then moving forward, we are also using the operator overloading here. We are initializing a box 3 object, and we are basically adding the box 1 and box 2. And here the plus operator is basically not a normal plus arithmetic operator. It is basically an overloaded operator plus, which is adding the dimensions of the box 1 and box 2. And we are also displaying the length and width and height of the box third, and display volume is also the function we are using. Display volume using function overloading. As you can see that we are calling both the functions for the same object, but we are not passing anything into it. So automatically it is able to understand that it is that particular function in which no parameter is passed. And we are when we are passing it with a parameter, it is automatically able to understand that we are calling the other volume function, which basically takes a parameter. So now moving forward to the OOPS concept, as I have told that OOPS are basically used to relate real world objects, real world entities to the programming, because everything in this world is an object. We can classify everything as an object. For example, if I talk about a house, so a house is basically consisting of rooms, but there are similar features of the room, so we can make it a class. And every room have some common features, like a room will be surrounded by four walls, then the upper surface, then there will be fans, there will be uh, curtains, there will be some more things, there will be almirah. So there are some common features associated with all the rooms, so that can be given to a class, and different objects can be made using that. So basically, class are blueprints for objects. An object is an instance of a class. Object is basically consisting of some features of the class, but also it can have its own feature. Not necessarily. Class are blueprints of for objects, and object is an instance of a class. Basically, it can have different properties, but the common properties are given in the classes. It basically gives an overview for object. Now, moving on to the encapsulation. Encapsulation is basically bundling data and methods that operate on the data within a single unit, restricting access to some of the object's components. So basically, when we implement OOPS, like in the before example, we used some properties, and we also implemented some methods like volume. So in this, basically we are encapsulating data and methods. So this is basically called encapsulation. And inheritance is basically mechanism to create a new class from an existing class, inheriting attributes and behaviors while adding new features. So in inheritance, we are creating We are basically inheriting features from the parent class. Basically, there is a derived class which is inheriting some features from the parent class, and it can also have its own features. And this is polymorphism. So, polymorphism is also one of the OOPS concepts, and polymorphism is something we can see in function overloading and operator overloading. In polymorphism, it is an ability to present the same interface for different underlying data types, allowing methods to do different things based on the object. As I told before, that when the volume function was called, automatically it was able to understand which volume function is being called. So this is basically polymorphism, which is taking a different form based on the reference, based on how it is being used. So this is polymorphism. Abstraction, hiding complex implementation details and showing only the necessary features of an object. So this is also abstraction, and we can implement abstraction using different access modifiers like private, protected. Uh, in this way, we can abstract the data. We can abstract. Abstraction is basically uh, that we are showing only the necessary details to the user, and we are not showing all the things to the user. So moving on to the embedded systems. So till the C++ part, all the coding part was done, and from here, gradually we moved to the implementation of the project. So embedded system, as we know, is in layman language, it is a combination of hardware and a software. So embedded system is basically a specialized computer system designed to perform specific tasks within larger devices. Like example of embedded system includes microwave, car engine, and line following robot, or there could be RFID attendance system. These are all examples of embedded systems. There are, of course, more examples. For example, drone. If we program a drone to do a particular function, so drone will be an embedded system. And refrigerator, washing machine. These are all examples of embedded system because they also have a code inside of them. It consists of a microcontroller or microprocessor, memory, and input and output interfaces. So, majorly, embedded system contains a microprocessor, microcontroller, which is basically the main part of embedded system, which is making all the operations happen. And then there are input and output interfaces. But there are many things as well. There can be many things like timer, program memory, parallel port, serial port, data memory, interrupts, power supply. These are also different parts of the embedded system, and these are all integrated on a single system. These are not externally included into it. They are on a single chip, and it is programmed and it is used inside a system to perform a particular task. And there are different types of embedded system like standalone systems which function independently, like washing machine. Washing machine doesn't need external support other than the power supply, which is necessary for every embedded system to function, but it doesn't require any other uh, system, or it is not basically dependent on other system to function. Like also there is one more type of embedded system which is real-time system which require timely responses. Like there are systems, embedded systems which are used in certain areas which are very sensitive. For example, if there is area where it is very much prone of getting volcanic eruptions, so there we cannot there we cannot afford to have delays. So if embedded system is used in such application where we cannot have a delay, because if we get to have some delay, so there can also be a sacrifice of a human body or any other living being. So there real-time embedded systems are used, then networked embedded system in which basically it is connected to external network for its functioning, like Wi-Fi routers. And moving on to mobile embedded system, which is basically portable systems which can be moved from one place to another. For example, a car is an embedded system, a smartphone is an embedded system which keeps on moving, each optimized for specific applications and tasks. Now, moving on, we learned about the basic overview of the memory, like memory consisted of basically three parts, which are primary, secondary, and cache memory. So, primary memory is consists of RAM and ROM. RAM is random access memory, and ROM is read-only memory. Random access memory is faster, but the problem with random access memory is that when the power is switched off, or if it's just off that particular window, all the data will be lost in the RAM. It is just used for the fast processing, or the data that is coming just now. It is just processed, and for that processing, for that instantaneous processing, we use RAM. But for storing the data for uh, in the permanent memory where it cannot be deleted, that for that we use ROM. So RAM is basically random access memory, which is way faster compared to ROM. And RAM consists of static memory, dynamic memory. ROM consists of programmable ROM, uh, elec electrically erasable, programmable read-only memory, and also EPROM. So these are different types of ROM. Secondary memory basically consists of all the permanent memories like hard disk, magnetic tape, CD, DVD, zip, disk, etc., which can be used for storing large volumes of data in the permanent memory. And cache memory is the memory uh, which is very much used again and again. So some of that data can be put on the cache, which keeps on using, which we keep on using on a day-to-day basis or on a very frequent basis. So we can keep that particular data on the cache memory. So the difference between RAM is random access memory. It is a type of volatile memory used for temporarily storing data instructions that a CPU needs for quick access during operation. As I told that it is for quick access. And ROM is a non-volatile memory used to permanently store firmware and essential system software. It retains data even when the power is off, but it cannot retain the data when the power is off. Static RAM is fast, reliable, and expensive, used for cache memory. Dynamic RAM is slow but cost effective, used for main system memory. For dynamic RAM, we need to refresh it again and again, and that makes it very slow. But the thing with this is that it is very cost effective. And static RAM is fast, reliable, but also expensive at the same time. But with the ROM, we see that uh, it can be programmed once and it cannot be altered. But EPROM is erasable with UV light. We can erase, basically, the full form of EPROM is erasable programmable read-only memory, which can be programmed. But if we need to erase the data, then we need to use UV light for erasing. And double EPROM is basically electrically erasable and reprogrammable, allows easy updates. So we can electrically erase this particular memory and we can write on it again. Now moving on to the IoT. So IoT refers to the network of interconnected physical devices that collect, exchange, and act on data through embedded sensors, software, and internet connectivity. So basically, IoT, as the name suggests, that we are connecting the devices through the internet so that they can communicate on their own and make us take wise decisions and also we take better decisions, fast decisions, and we can just save a human life, we can save time, we can save resources. This is basically the usefulness of IoT. So as the image suggests that there are different sensors. Here we can see that there are different sensors implemented here, and each of the sensor is gathering the data and it is sending it to the IoT gateway, which is basically collecting all the data, and it is performing some operations on that data to get some useful insight out of the data, and then it is just giving that data onto the internet, and through the internet the user can access in all around the world, or means wherever that particular person is, or all the person means the data is accessed by the user, through which he or she can know what actions they need to take. So it can be used in transport and logistics. It can be used on smart metering, smart grid system, parking sensors, waste management, smoke detector, home automation, wearables, and process monitoring control. It can also be used for cattle management. It can be used for climate, agriculture monitoring, livestock, environmental monitoring. There are various applications of IoT. So in this video, we will be able to understand about IoT on a much better way.
The internet isn't just about computers anymore. Now, all kinds of everyday objects can connect to the internet, including cars, thermostats, sporting equipment, refrigerators, and even shoes. This is known as the Internet of Things. Now, you may be wondering, why would shoes need to connect to the internet? Well, the shoes can collect data, like how many steps you take, which can be viewed from another internet-connected device like a smartphone. All the metrics collected by the shoes can be analyzed to tell you how many calories you've burned, give you personalized fitness advice, and much more. But the Internet of Things isn't limited to consumer products. There are city trash cans that send alerts when they need to be emptied, sensors on bridges that check for stress or damage to its structure, and many more examples extending to healthcare, manufacturing, and agriculture, among others. Unfortunately, there are also new security concerns. For example, if you have internet-connected locks, a hacker might be able to unlock your front door remotely. And there's the issue of privacy. All of these devices are collecting large amounts of data that can capture your actions and location throughout the day. Often, we don't exactly know all that is being collected or how this information is being used. The Internet of Things is going to grow exponentially over the next few years, bringing with it new benefits and challenges.
So in this video, basically we see how Internet of Things is used in a basic shoe, and how the data from that shoe we can use for getting some insight. There are various applications that IoT has, and if I talk about the project we are implementing, like home automation project we are implementing in this presentation, basically what we are doing, we are controlling the lights. Uh, we are controlling heater and cooler from all around the world. We can be in at anywhere in the world. We just have internet access, so we can control the heater and cooling system in our house. Uh, and we can also control the cereal tank. We can also see the temperature. So these are all the applications. So basically, this is just one of the application of the IoT. IoT can be used for much bigger application. For example, if there is a patient in the hospital, so or if it is if that person is not in the hospital, that particular person is staying in the room, but if that particular person is very uh, feverish or not feeling well or is in a critical condition, so we can just embed it some sensors, and that particular sensors can sense the data from his body and can send to the data to the nearby hospital so that they get to know about his health. And if they see some abnormality in the values of different sensors, so the action can be implemented on a faster way. So, moving on to the Blink app. So, Blink app is also one of the uh, key components in our project. So, Blink app is basically a platform designed for controlling, monitoring, and managing IoT devices through smartphones and web dashboards. And it has a very user-friendly interface, and it supports real-time controlling and monitoring, as I told before. And it supports hardware like ESP8266, which is basically Node MCU. It also supports Arduino, ESP32, Raspberry Pi, and it also gives cloud connectivity, utilizes Blink Cloud for secure, seamless communication between IoT devices and the app, ensuring data integrity and availability. Data logging and visualization is also supported in Blink app. Notification and alerts are also supported in the Blink app. Customization and scalability offers customizable widgets and dashboards suited for both personal projects and scalable industrial applications. So we cannot just use for personal projects, but it can be used on a industry level as well. So moving on to the project overview. So basically in this project, what we are displaying, what we are doing, we are basically using a heater and cooler control, and we are implementing garden lights. Garden lights are basically getting switched on and switched off based on the intensity of the light on that particular sensor which we are using, which is a LDR sensor. Cereal tank which contains the water, so we want some threshold to be maintained, some certain volume to be maintained on the tank, which is also implemented in this project, and we are displaying all this information on the CLCD, which is basically character liquid crystal display, which is basically used to display the characters. And we are also integrating Blink app along with it. So, moving forward, what are the detailed implementations? So, moving on to the garden lights. So, what we are doing, we are using an LDR sensor. So, what does LDR sensor do? So, basically, LDR sensors read the LDR sensor value based on the reading from the LDR, vary the brightness of the LED. So, LDR is basically light detecting resistor, so light dependent resistor. So there is a resistor which depends on the light. So basically, if the light, and using that values, we are controlling the brightness of the LED. So basically, LDR is connected to the LED. So if the light is more, okay, if the light is more, so the LDR sensor value will be less. Okay, if the sunlight is more, LDR sensor will be in accordance, so that the LED must be less. LED brightness must be less, and if the brightness uh, If the brightness that is being uh, concentrated on the LDR sensor is very less, so automatically the LED brightness will be switched to the higher value, and it will happen automatically. It will not be at particular instant. It will be continuous in nature. So this is the implementation we are doing. And temperature control system is basically we are using LM35 temperature sensor, which is basically sensing the temperature, and also it is getting displayed on the gauge widget of the blink app and also on the CLCD. And similar way, we are controlling cooler control system, and using the blink app we are able to switch on and switch off the cooler, and it will be displayed on the blink IoT app, the widget, and also it will be displayed on the CLCD that we are also switching on the cooler and switching off the cooler. Now heater control system, same way as cooler control system, we are making a widget for controlling heat on the blink app, and also we are also writing on the CLCD when the heater is on, and this is the application we are doing. And threshold temperature control, we are also doing that. If the temperature rises more than 35 degrees Celsius, then the then the heater must turn off automatically. Heater must turn off automatically. So, and the same should be displayed on the CLCD. And in the blink app, the heater must turn off. If it is on, the heater must turn off automatically. Then using different sensors to read the volume of the water, we are also displaying the volume of the water on the CLCD. And then we are also controlling inlet valve control. If the button widget is at logic high, turn on the inlet valve, and if it is off, then we have to turn off the inlet valve. So we are making basically a widget for controlling inlet valve, just like heater and cooler control. Now, the last two applications are outlet valve control, which is also same way outlet valve to just pour out the water. To use the water, we are using the outlet valve, and the same widget will be provided on the Blink IoT app to control the outlet valve. And also, we are displaying the same on the CLCD when the outlet valve is on or off. Then again, just like the temperature, we are controlling the volume of the water, which is basically 2000 liter threshold. We are maintaining a threshold of 2000 liter. Volume should not go less than 2000 liter. So different components that are required on the CLC on this project is LED for controlling the garden lights, temperature system along with the ADC, uh, LM35, LDR sensor, serial tank, CLCD, Ethernet shield to connect it to the internet, Blink IoT app, Pixim Lab, which is basically a simulation software, and Arduino IDE for writing the code. Now, these are the two reference images. Like this is the reference image of the uh, LCD. This is how we want the temperature to get displayed, volume to get displayed, and here it should be written if the heater is on or inflow is on. And this is the interface of the Blink app. Like if I want to switch on the cooler, so I should just press this button and it should get turned on. This is for the heater switch, this is for the inlet valve, this is for the outlet valve, and this is the gauge widget, which is used to display the temperature. Now let's see the project demo. So let's open the Pixim lab. Let's Let's open the cereal tank. In just 1 minute, I need to mirror my. So here, basically, we are controlling through the Blink IoT app. Before that, uh, I will just connect the cereal tank, and I will also load my hex file again. So here we can see the display of the Blink app, cooler switch, heater switch, inlet valve, outlet valve. So here you can see that the inlet valve is getting on its own, and it is getting on, and it will fill the tank up to its full capacity, but I can stop it after 2000 liter. But right now, if I try to off it, it will automatically get on because the threshold is not yet reached, and the temperature is getting displayed. The same temperature is given on the gate widget, and inflow is on. The same is getting displayed here on the CLCD, and you can see that it is stops and automatically it gets off. So if I switch on the outlet valve, so you can see that the water is getting poured out, and the same is getting displayed on the CLCD, outflow on, and at the 2000 liter inlet valve automatically gets on. So basically it is maintaining a threshold. And if I just off my outlet valve and I fill it up and I just off it, then this much water will be contained in my cereal tank. So the condition part, as well as the volume displaying part, as well as the inlet valve and outlet valve, all are being controlled. All requirements are being fulfilled in this particular cereal tank programming. Now, let's see the temperature and cooler system. So I'm just switching on the cooler system. So if I switch on the cooler system, the same is getting displayed on the CLCD, and it is getting switched on. We can see that the fan is working, and the temperature is not means the temperature cannot go less than this. Now, if I just switch off the cooler and I put my heater on, so the same will be displayed here, heater on, and it will rise the temperature. And as it will reach more than 35, automatically heater will be off. As you can see, if I turn on my heater on and it goes beyond 35, the heater is getting turned off automatically, and heater is off. The same is getting displayed here, and the same data is the same temperature is getting displayed here on the temperature widget. So now let's just put on my cooler switch on to see if the temperature is getting less or not. So we can see that the temperature is getting less, but the threshold is 27.34, and the same is getting displayed here as well. Now let's see the LDR sensor. which is basically the implementation of the garden lights. These are my garden lights, and I'm controlling it through the LDR sensor. So right now, the brightness is at its peak, which means that it is dark night. It is the brightness is very less. That's why the garden lights are lighting up on their maximum capacity. But as I scroll it down, so I can see that it is getting more dim and dim, which basically represents that right now the sunlight or the external brightness is very high, so automatically the brightness is low. But as I turn it on, the brightness will automatically grow. So this is the implementation of my project. And at last, I would just like to say thank you to Jayalaxmi Ma'am, our mentor, and also Emertxe Information Technologies for providing student like us this opportunity to learn the concepts and to learn how to implement such projects. Thank you very much.